In today's lesson, we're going to go over simultaneous equations and how to solve simultaneous equations. And let me just start off with an example of what we mean by simultaneous equations. So let's say that we had 2x plus y is equal to 5. And we were also given another equation, 3y is equal to 1 minus 2x. In this case, we have two variables. We have x and we have y in both of these equations. But while we do have two variables, we also have two equations that we can equate, and we can use these two equations to solve for two variables. And this is slightly different than what you've been doing in previous examples thus far, because as we've seen, we have been dealing with equations in which we only have one variable present. And when you only have one variable, it's relatively easy to solve for that variable once you move all your constants to one side and keep your variable to the other side. But in this case, we have two variables, but we also have two equations. So I'm going to go over two different methods that you can use to solve simultaneous equations. And the first of those methods is the method of substitution. And in substitution, what we're going to do is we're going to use these equations and try to, in one equation, rearrange to solve for one variable and put that variable in terms of the other variable, and then plug in that other variable in this second formula. And that might sound confusing now, but let's actually just look at an example of that. So let's first try putting this first equation as one variable in terms of the other. And what I mean by that is let's try and isolate one variable in this equation. So I think the easiest one to do in this case will be y. So let's keep this y on this side, but let's move this 2x to the right-hand side of the equation. And so that first equation is going to become y is equal to 5 minus 2x. And now in our equation, we have isolated for y. And now what we can do is we can take this second equation and we can plug in this value for y in the second equation. So this equation, number 2, is going to become 5 minus 2x, and that's because here we have y. So we're just plugging in this value for whenever we see a y in this equation. So that becomes 3 times 5 minus 2x is equal to 1 minus 2x. And now you can see that in this equation, we only have one variable. We know how to solve equations in which we only have one variable. That's just the same way that you would solve any linear equation. And so we can expand this out, and that would become 15 minus 6x is equal to 1 minus 2x. Let's move our variables and our constants to respective sides. So we will have 15 minus 1 is equal to minus 2x plus 6x, and that will be 14 is equal to 4x, and we can now divide both sides by 4, and that will give us x is equal to 14 over 4. And we can actually simplify this further as 7 over 2. If we divide both sides by 2, we'll get 7 over 2. So that's the most simplified form of x. So now we've solved for x in our equation. And what we can do next is we can plug in that value for x into any one of our two equations and find a value for y. So let's give ourselves a little bit more space first. Let's actually plug in this value for x into our first equation. And if we were to do that, then we would get y is equal to 5 minus 2x, and our x here is 7 over 2. And so that would become 2 times 7 is 14, over 2 is 7, so that would just be 5 minus 7, which is equal to minus 2. So our y is equal to minus 2. And that is how you are going to use the method of substitution. So you can see we've now found a value for x and we found a value for y. And to recap, the way that we did that was we started out by just rearranging one of our equations to isolate for one variable and put it in terms of another variable. So here we isolated for y and put it in terms of x. And then we substituted this equation for our y. This was originally 3y is equal to 1 minus 2x. So we plugged in this value for y. and then we had only one variable to solved for that variable, and plugged in that value for the variable into the second equation, and then solved for the second variable. And that is the method of substitution. Now let's go over the second method that you can use, and that method is the method of elimination. So let's start off with an example to illustrate the method of elimination. Let's say you had 2x minus y is equal to 12, and 4x plus y is equal to 9. Now, in the method of elimination, what we're essentially going to be doing is we're going to either be adding or subtracting our two separate equations together in order to eliminate one of our variables and get a value for the other variable. So I have our two equations written down here. And one thing that we can notice is that we have a minus y and a plus y here. So if we added these two equations together, our minus y and our plus y would cancel each other out, and we would only be left with x's to deal with. So let's actually do that. If we were to add these two equations together, we would have 2x plus 4x is equal to 6x, minus y plus y is going to cancel out, so we're going to get plus 0, and that is going to be equal to 12 plus 9, which is 21. And now to solve for x, we can divide both sides by 6. So we're going to be left with x is equal to 21 over 6. And that is equal to 7 over 2. If we divide both of these by 3, we'll get 7 over 2. So now we have a value for x. And now we can plug in this value for x into either of our equations and solve for y. So let's try plugging that in for the first equation. So let's say we had 2 times 7 over 2 minus y is equal to 12. And that's just plugging in this value for x into this equation right here. And if we solve that, that's going to be 2 times 7, which is 14, divided by 2 is 7, minus y is equal to 12, and we can move this minus y to this side of the equation and move this 12 to this side, so we would get 7 minus 12 is equal to y, and we would then get a solution for y is equal to minus 5. So now we found a value for x and a value for y, and that is how the method of elimination works. So we basically are going to either add or subtract our two equations together to cancel out one of our variables, solve for the other variable, and then substitute that in to one of our equations to get our second variable. It's worth noting that no matter what two equations you get, both of these methods are actually going to work. Both substitution and elimination can work to give you the right answer, but the method that you use is going to differ based on the kind of equation that you have. You could solve this just as easily if you were to move this to the other side and just isolate for y in terms of x and then substitute that back like we did in the previous example. But because this equation has a minus y and a plus y, it's easy for us to actually solve this by elimination, and that's going to be the preferable method that you'll use.